Okay, in this section 7-6, our topic is classifying triangles, part 2. 7-6 happens to be the last section for Unit 7, so we will be done with the unit after this section. And so the first thing that we want to take a look at is some notation type things that we need to make sure that we clear up. So remember, when you're labeling a triangle, the capital letters are the 3 vertices, right? And the lowercase letters can represent the sides. So instead of just listing them out as segments, like for example, segment AB, you can list this side as side C. Okay, so the capital letters are reserved for the vertices, and the lowercase letters can represent sides. Now, here's the case, or here's the key. All right, if this is angle A, then lowercase side A has to be the side that's across from angle A. All right, so side A, which is segment BC, it's got to be across from angle A. And likewise with the other two. If this is angle B, the one opposite of it, across from it, has to be side B. And then side C has to be across from angle C. So you can't just mix up the side letters. Like I can't put A over here unless I put angle A over here. Does that make sense? So the side should be across from its matching angle. They should be the same letter, just one capital and one lowercase. All right, so keep that in mind notation-wise. Okay, also, the next thing that we come to that we're going to be utilizing here in this section is a theorem that says for any triangle ABC, where C is the length of the longest side, these following statements are true. All right? So if A squared plus B squared is greater than C squared, then the triangle is acute. So in other words, if the A squared plus the B squared part is greater, the triangle has to be acute, less than 90. All right? If the A squared plus the B squared equals the C squared, then we know from the Pythagorean theorem that it is a right triangle, right? And if the A squared plus the B squared is less than the C squared, then we know that the triangle is obtuse. Okay, so if the A and the B part, squared part, are more, it's acute. If they're equal, it's right. And if the C squared part is more, then it's obtuse. All right? And so let's just kind of take a look at how we can utilize that. Now remember, C is the length of the longest side. So the key to using this theorem is to make sure that whatever the longest side of the triangle is what you plug in for C. All right, so if I were trying to classify this triangle, for example, okay, what I would need to do is locate, first of all, where's the longest side? The longest side is 8, so I need to test this. 6 squared plus 7 squared. All right, and I need to see how that compares to 8 squared. All right, because I don't know what to put in between here yet. Okay, so let's take a look at the numbers. So 6 squared is 36, 7 squared is 49, and then so 36 plus 49 is 85, and 8 squared is 64. So what that means is the A squared plus the B squared part is greater, which means the triangle itself has to be acute. So acute is the right answer there. Okay. So again, you're just testing the numbers. So here, 5 is the biggest one. So we'll go 3 squared plus 4 squared. And we want to see how does that compare to the 5 squared that we have. And so that would be 9 plus 12, 9 plus 16, 4 squared is 16, which is 25. And I want to see how that compares with 5 squares, which is 25. They're equal. So since they're equal, we know that this is a right triangle from the theorem, the middle statement. Okay? All right, the last one, what's the longest side? It's 18. So I'm testing 8 squared plus 12 squared. And I want to see how that compares with 18 squared. Okay, so that would be 64 plus 144, which is going to be 208. And 18 squared is 324. So that means the C squared part is greater, which by the last statement will cause this triangle to be obtuse. Obtuse is the correct answer there. Okay? All right, some more types of problems that we need to look at here. And so the directions here say to tell if the sides make a triangle that is acute, right, obtuse, or if it's not a triangle, if it's not a triangle. So the first thing we want to make sure of is that it's a triangle. And remember from last semester, I believe in Unit 4, we learned that any two sides added together have to be greater than the third side. And so you got to check the biggest side. So is 6 plus 8 bigger than 9? The answer is yes, so we know it is a triangle. Now we just need to figure out what kind. 9 is the biggest one, so that'll be C. So I need to compare 6 squared plus 8 squared to 9 squared. And so that would be 64 plus 36, which is 100. And we're comparing that to 9 squared, 81. The 100 is greater, so the A squared, B squared part is greater, so that's acute. All right. And so for the next one, okay, 20 is the biggest one. 10 plus 4 is not greater than 20, so this is not a triangle. Remember, any two sides added together have to be greater than the bigger side. So these two sides have to be bigger than 20. They're not, so you can't close it up and make a triangle out of that. All right, so for the next one, 12.2 is the biggest. 14.1 plus 8.2. It is going to be bigger than 12.2. Not by much, but it is. So it still can make a triangle. So we'll go 4.1 squared plus 8.2 squared. And we want to see how that compares with 12.2 squared. Okay? So 4.1 squared plus 8.2 squared, we can take that and plug it into our calculator. And when we do, we would find that that's 84.05. And if you were to do 12.2 squared into the calculator, you would find that's 148.84. And so the C squared part of this is greater, which is going to cause the triangle to be obtuse. All right, so there you go. Okay, one more that we need to take a look at here, and that is going to be this last one. Now, 5 square roots of 13. What we'll have to do there is we need to plug that into the calculator and kind of see what that's going to be equal to so that we can tell whether it's longer than 15 or not, right? So we can tell what our C is. So one of the calculators, of course, that I've recommended to you guys before is Desmos. It has an app. It's called Desmos Calculator. So if you go ahead and put that in there, you can put 5 and then square root of 13 right in there, and it'll tell you right away that it's 18.03, we'll call it. So 18.03. Okay? And so now we know that that side is indeed the longest side because 18.03 is longer than 15. So, and we can test if it's even a triangle. 10 plus 15 is greater than 18, so we're good. So let's test it. So I need to go 10 squared plus 15 squared, and I'm going to compare that with 15 square roots of, or 5 square roots of 13, that whole thing squared. And that's how you need to plug it into the calculator, by the way. Make sure you plug it into a set of parentheses when you square it. So that on this side is going to be 100 plus 225, 325. And if you were to plug this into the calculator, then you would also actually get 325. And so they are equal, which means that's going to be a right triangle. Okay? And so just to kind of show you here, if I go back to my Desmos calculator, if we were to take this thing in here now and, whoops, I don't want that parentheses. I want the whole thing in a set of parentheses. So we will close it out there and then square that thing. Then you would see it is exactly 325, which makes it a right triangle. And so at this point, we're done with the section, and we have actually also completed the unit.